Okay, welcome to Module 4, to Introduction to Python with me, Yaakov. If you made it this far, rock on. You are pretty far ahead, and you're now going to see some of the power of what you could do with some code. If you use Excel or you use any other business intelligence tool, prepare to have your mind blown, because we're going to do some really simple things that are really, well, we'll do some really cool stuff. So let's go on with the lesson. So this image is pretty, and it has done its job. This is going to be a link that you have access to. This is the GitHub repository to the project Intro to Python, and you will go and find Module 4. Quick note, if you want to join the classroom I built, you can use this code, and you can take homework and do all the homework. Okay, this is the file. It's going to look a little different. I gave a little header up here. It's going to look a little weird. Go ahead and click that. And you're going to be opened up in Google Colab. I'm going to pour myself a coffee. Yeah. I'm playing with the lighting of this video, so you'll tell me how it works if you like it. It's a French press coffee. It's a little bit light. I like my coffee light. Okay. And remember, you're a programmer now. You can drink coffee whenever you like. So to connect, you're going to click up here. Google's going to spin up a virtual machine for you. You don't have to know what that is. Just click connect, and now you're good. Hover over any cell, and you're going to run the cell. You click right there. It's going to ask for permission. It's just making sure that you know the code wasn't written by Google and that it's code you found on the web, and you give it a run. And then you're not going to see anything because this cell doesn't have any output, which is okay. So let's do a quick introduction to what's taking place here, and then we're going to get going. So Module 4, we're analyzing big data. We're going to be measuring big data for Hamilton, the Broadway musical. And we're going to be measuring we're going to take all their financial information. We're going to ask them specific questions like, what was their best week? And what's the best week of the year for them? Okay, so you've got your little description up here. This is a text. I'm not going to go into the data that I read in the previous video. So outline, we're going to load the data. We're going to rename the columns, which is not as easy as it sounds. We're going to clean the data. We're going to aggregate the data. We're going to use time series. And we're going to visualize. Okay, so if you didn't run this cell, run it again. Now, a little bit of a housekeeping. You can either run by clicking the go button every single time, or you can click inside a cell and you can hold shift and press enter. And that's just going to run the cell and move you to the next one. On a Mac, if you want, well, on Windows, it'll be the same. If you want to run the cell but put a new cell beneath it, I believe it's going to be on a Mac, option enter. And that will create a new cell beneath it. And if you want to delete a cell, you can delete a cell here at the bottom. Or you can do Control and D, which is, I don't know why it's very long, but that's what you could do. Okay, cool. So we know how to run code. And this little thing will tell you the number that refers to the number in which that cell was run based on all the other cells you've ran. So if you do 1, 1, 2, so 1, 2, 3, 4, 5, so I ran 6 cells total, and that was here. Okay, it's kind of a little bit confusing. So we're going to load and pre-process data in section 1. We're going to load the data all at once. So in 1, we're going to do it like little pieces, and then we're going to do it all over again in 2 in one little section, just so it's neater. 3, we're going to analyze some stuff. This should be a subsection, so we'll skip it. And then conclusion is going to be just a little bit of a little paragraph. Okay, so let's get going. So we've loaded our modules up here. Open up section 1. We're going to load and pre-process data. So I got this data from Broadway World, where they have the gross information, the gross data. So we go here, right? You get to see all the interesting things. If you scroll way to the bottom, you can export the complete show to Microsoft Excel. You can do that, and then what you would need to do is you would need to convert it to a CSV. Only because their Excel format is not compatible. Save yourself a headache. Or you can just use the file that I have provided for you. You can click on it. It's going to take you to a Google bucket. It's going to try to download it. So we don't want to download it. What you're going to do is you're just going to feed into Python, and Python's going to do it for you. So we're going to actually load the data. I had renamed it from another instance. Okay, so what you do here, you're going to run this cell. This cell is going to give you the data path. This link up here, and then what you're going to do is you're going to get the text. Okay, so we're saying get me whatever is in this file, and most data on the internet, almost all data, is transferred as text, as strings. So if I print the data, it is this thing, and it is a string. So if you work with data a lot, you'll know that CSV stands for comma separated values. So you see here, the first value is March 8th, 20, separated by a comma. You've got the next figure, right? So you have all your figures separated by commas. And that's a big text blob. So I can break them up into sections, and I can zip over them and break them by commas and put them into lists and put them into, wow, that's a lot of work. So luckily for you, there's people on the internet who put their time into open source projects, and they make things like pandas available for you. So instead of doing all this complicated data manipulation, you could just call pandas directly, and you could say read a CSV, because this is what the files look like, and put in the path. That's all it's going to be. If this is a local path, so if it's on your computer, you'll say / folder my data / name of the file .csv. Then you're just going to run this, and I'll show you how easy it looks. Boom. Much easier than taking the previous text string and breaking it up into pieces. And this looks a lot more familiar, hopefully, right? This looks like what you might see in Excel. You have your columns. Columns go up and down. Think of Greek, the Greek Pantheon, and rows, whoosh, sideways. And I got no heuristic for rows, so just if that ever confuses you, and it's okay to be confused because maybe you just never learned columns and rows, Google it. What columns and rows? Let's just see if Google will help you. There you go. Yeah, Google's got some great resources, some images here. Okay, so what's taking place behind this image here? So first, not this image, this data structure. So first, let's get a few things here. I'm going to print a cell. I'm going to say print the type of DF. So DF stands for data frame. Now you might want to name it something special and specific. Hamilton data. Don't. Name it DF, because DF is a standard. People who are going to read your code need to be able to understand it. People name it all the time DF. If you need to say this is Hamilton data, you can give yourself a comment. This is Hamilton data. Later instances, you can say DF Hamilton equals DF. I would not encourage you to do this. Okay, you could if you needed to, but try not to. Try to just use DF, and if you need to use multiple data structures, then combine them all to one, or use one at a time, delete the one you're not using, open up the file again, and you can read and write. This is a very, when you read and write objects, it allows your machine to optimize the memory store, but also it prevents you from misusing data structures. So the last thing you want to do is say, yeah, open up Hamilton show and tell me their best week. Okay, now do that for, choose another show, your favorite, Dear Evan Hansen. Get me their best week, but you accidentally use Hamilton's data, and now you think that they're the same, and maybe they are, maybe they're not, but you don't want to mess up. Okay, so printing up a type will tell us that this is the class is a pandas core frame data frame. This basically is this, it's a data frame. Okay, so in the data frame is this. There are columns, there are rows. In each row or cell, there's a data type. There's a data, right? So here I have week, and then in week, oh, I shouldn't click so much, it makes annoying sounds. Week, and then this I have is a data type, right? So we're going to get into what these data types are and how you manipulate them, okay? So just for you to understand what's taking place here, I have my big data, and then inside there are pieces. Now, quick question, like what's the difference between big data and small data, right? This is analyzing big data. Here's what I would say. Big data means you can't see it all at once. So if you take like exams when you're maybe a high school student, if you're not a high school student yet, when you'll get to high school, they'll give you a little question. Johnny ate 3 piece of cake, and Sarah ate 5 piece of cake. Right? And they'll show you a little chart. That's small data. You can see the whole thing at once. Big data is every single person today in your neighborhood who ate a piece of cake. Well, I mean, it would be more than 20, maybe a couple hundred. So for this, if we were to print out the entire data frame, however many weeks Hamilton's been on Broadway, it's upwards of a couple hundred. So that's how big it is. You can't look at it all at once. But you could see all the columns. So this is only 12 or so columns. Imagine dealing with a data set with, 250 columns and 5 million rows. Ooh, I should put that on mute. I did put it on mute. All right. Well, I'll just hope my notifications will come up again. Okay. So there's a few things that we notice right here. We say the data isn't right. We need to rename some of the columns, right? First of all, money signs, not good. Computers don't like the word money, the money sign, because money sign for us is, for a computer, it can mean all different sorts of things. Also, there's apostrophes here. That's not good. Apostrophe means the end of a word, end of a string, so that might get hairy. We want to get rid of those. Also, what's taking place here? Seats sold. This should be one column, right? This should be one, not split across 2 rows. And this whole row is empty, besides for seats total seats. So we want to rename these columns. We also want to get rid of some of the rows. So let's do that. Okay, so this was a quick peek. And what we're going to do is we're going to create a backup of our data. Now, I'm just doing this to show you what it would look like if you were ever working with data and you load it up here and you do all this crazy stuff and then all of a sudden you mess something up, you want to be able to get back to what you're working on. You can create a backup. And backups are different than just making a copy. Because if I just want to make a copy, I could just say, df backup equals df. The reason why you don't want to do this is because, and this will be true for certain data types and not for others, but basically, when you make a copy of the first one to the second one, it just renders the variable name and it points that variable name back to the original data. So imagine you have your data frame takes up 250 megabytes, pretty big, right? And then you want to say, okay, call this thing another name. So now it's going to say this is df, and this is also df backup. So if you make changes to df backup, it's going to be made here, so everyone gets the change. So in order to make the change complete, you have to say make a copy. So it's going to make 2. So you'll have df and df backup. And some of this has to do with how memory is stored on a chip level. And since you're not a computer scientist, if you want to be, then go for it. But if you're not a data scientist like me, if you're not a computer scientist, I'm not a computer scientist, then you probably don't want to know what's taking place on the chip level, which is totally cool. And for that, I'd say when you make a copy, just tell the code copy and say deep is true, which basically means make me a legitimate copy. If you have a big data structure, this is going to make your computer get slow for a second, but only use this when you're playing around. Don't do this in production. Okay, so let's talk about renaming some columns. And I'm going to try to go a little bit quicker because I tend to ramble. So in order to rename columns, I could say, here's the one I want to rename, this week's gross. So I can just rename one at a time. Okay, I could say df dot rename, and then it doesn't know what I'm renaming. It thinks I'm renaming rows, so I say columns equals, and you're going to say it equals a dictionary. And the keys are the current names, and the value is a new name. And if you rename the column, and you say, well, let's see what it looks like here. Well, no, I'm just going to do that here. Rename. Yeah, we'll do it one at a time, actually. So I'm just going to run this. I'm just going to run this without code. I'm just going to run this without anything. So, okay, rename. So, well, let's run it without. Let's just do df. Okay, this week's gross. That's what it looks like now. And then I'm going to say this week's gross equals gross. And boom, it replaced it. Wonderful. Now, what if I mistype it? What if I say this week's gross with a Z there? It doesn't rename it. There's no error. It just tries, it looks for the column that I specified and it tries to rename it. But since this column doesn't exist, nothing will get renamed. So you have to be very, very clear. This can get crazy, especially when you have different things going back and forth. So you want to make sure that you're renaming properly. Okay. So this does the job. Great. So let's go back here. Now, if you just do this, nothing's going to happen. It's just going to rename it and move on. And it's not going to save the rename. So in order to save the rename, you can either do df equals this, which is not an ideal form. There's a better way to do this. And I'm not really going to get to why, but instead of saying df equals df.rename, you put in the function, you say in place equals true. And what that's going to do is it's going to rename it, and it's going to adjust that change to the original data structure. It's different than making a copy, because the copy is going to point back to the original data, and it might make a whole nother copy. It might make a copy error while it's doing that. We won't get into that. But in order to save the change in pandas, you say in place equals true. So now I'm going to rename it. And boom, gross is now equal df. And if I get rid of this, it's still persistent because I've already renamed it. And there's no error because it's looking for this week's gross. It doesn't exist. It moves on. Okay. This is the alternative way. Right? This is the way I said don't do. This would work, but don't do it. Okay, great. So we've renamed one column, but I don't just have one column I want to rename. I have all of them. I want to rename all of them. So you're not limited. So what we're going to do is we're going to create a dictionary. And I did this manually. There's faster methods, but if this is your first time working with big data, take the extra 2 minutes and just hard type out the names of the columns. It'll make your life a little easy. You're not here to figure out how to rename columns. You're here to get to the analysis part. So cheat. That's what they call hacking. All right, so you just manually type out all the names and columns. And if you see here on the left, on the keys, here are the current names. And on the right side, these are the names I'm using. Some of these names are industry terms. So I won't get into what these are just now. I will get into what they mean when we use them. Actually, I'll tell you quickly what they mean. Okay, week is the week of the show. Gross, which they have this week's gross, is how much money did the performance yield. That doesn't mean the profit. It doesn't mean the revenue. It means this show had how many seats purchased and how much does those seats, how much value do those seats generate? And that is what's applied. If everyone bought their tickets 3 months ago, the gross for 3 months ago is 0. The gross is for today. Okay. Last week's gross. If you don't want to look at the previous cell, you can just look here. So we know that this is the first week, July 19th, 2015. Okay, the potential gross is how much money could they make if every seat is sold at the price that they're offering it. And you'll be surprised, sometimes the actual gross exceeds the potential gross. There's different reasons for this. The potential gross is, think of it as like a technical number. It doesn't really represent an actual one. Right? Then you get that as a percentage. You have the average ticket price, you have the top ticket price, you have the number of seats in the venue, you have the total number of seats sold, you have the number of performances that week. Usually you'll see 8 performances, sometimes there's 7, sometimes there's 9 in occasion when there's holidays. And I think I once saw 10, but it was like a gap. It was like a calendar thing. So that's something you might see. And this is a Broadway regulation specified by Actors Equity Union. And if you ever see a number that seems weird, use your brain, Google it, find out if it is or isn't. And it's always cool to hit up Twitter and message someone, because I guarantee you someone in Broadway will respond, because people are really kind. Okay, and then this week is the percent. So this week percentage is the capacity percentage. So how many people, if the theater can fit 100 people, how many people are sitting there, make that a percentage. Okay, last week's different. Okay, so now you know what these names are. We're going to rename them to more proper names. Okay, so I create my dictionary, and then we're going to rename them down here. df.rename. Open up my parentheses, columns equal my dictionary, and keep the rename. Right? I'm holding my coffee, so I'm going to manually click it. Great. So you don't see the output, and we want to see it. So I'm just going to just show you. There we go. Much better. Week, gross last week, gross diff, gross potential value, all these things that we like to see. Awesome. Let's move on. Alternatively, you can use a list. So what I've done is I've manually copied the existing columns, the ones that we want. And this, I would not say that you should use this method, because this method only works if the columns are in the order that you want them. So if I know that this is the order of the columns, I could just say, assign to the columns these names. It's that simple. And I'll show you what that looks like. Okay, so here I'm going to change week. I'm going to make week with a Z at the end. Right here it's gone Z. I'll put a Z here too. Okay, so now it's just going to put these phrases, and I'm just going to get rid of them because that's nonsense. And if you know the exact order, it's easy. So if your data frame only has 2 columns, this might be a useful solution, especially if the 2 columns, if you're doing like exploratory analysis and you're going to throw out the code at the end and you just want to get an answer, then sure, make them a list. But the best, most replicable code are ones that use either dictionaries or list operations. I'll give you an example. So we have a list here. Okay. There's some other really cool ways, some other cool things. I can make them all lowercase. So this is done through, there's a string method to append a series. So think of every row or every column being a series. A series is just, think of it as a row or column. Okay. So you can say df columns, which is going to be a series of all the columns, week, gross, whatever. get me the string, so it's going to go into each one. It's going to treat each one like a string, if it's a string, and make it lower. So I'm going to make them all lowercase. I'm just going to just print that what that looks like. Okay, so now everything's lowercase. Great. So I can say, all right, and I didn't save them, right? So it's my original columns are not renamed. So I could say, okay, I don't care about them making lowercase, but replace all the spaces with underscores. That's really useful if, well, print it. That's really useful if your code can't have spaces. There's plenty of times that'll take place. Now, what if you have, so this is great, this works. What if you have multiple spaces? So like whoever submitted the code, whoever submitted the CSV, like it's saved weird, and now there's like space, 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 space. And when you type it out, you don't have one space, two spaces, make it crazy. So you can use regular expressions to get rid of multiple spaces. So similarly to .string replace, you can do .string replace, and this is the regular expression for /s means, this part means anything that's a space character, tabs, new lines. Plus means if there's more than one, if there's one or more. Replace all of those, the one or more, so you get space, tab, space, replace all that with a single underscore. And you have to tell replace. Use regular expressions, otherwise it's not going to know what you're talking about, it's going to break. If I do that, it looks the same, and that's because our columns look totally fine. They don't have multiple spaces. Great, so that's a way you can do that. Awesome. We're done renaming our columns, and if you look back to, well, I mean, we already did it. Great. So I'm going to collapse the rename columns. Well done. Let's move on to 1.2, dropping rows or columns. This is a little bit easier to fathom, but a lot easier to mess up code-wise. So if you made an error, just do a quick sanity check and make sure that your headers are good. Okay, that's something I would suggest. Whenever you do manipulation, do a sanity check. Does my data look the way it needs to look? Just open it up, be like, yeah, okay, good, I'm not crazy. Now you can delete it. Well, I'll just caption off. Okay, so how do you get rid of a row, right? So let's look at the first row again. This is not good. I don't want it. And I got rid of the sold seats. I don't need that. I can get rid of the whole first row. So how do you do that? So to drop a row, you do df.drop, and then the number is not the number of the row, it's the index of the row. So an index is the number here you see to the left. Okay, you notice how it's indented, right? So that means it's an index. I could say get me 2, which is going to be the week of July 26th. So 0 is the one I want to get rid of. All right, we already know in place true, so that we don't have to review. Just going to save it. There's one more thing: errors ignore. So with columns, what rename will do, it will look for the column. If the column's not there, it will skip it. With drop, it's going to try to drop that index. And if it doesn't have the index, it's going to break. So you have to tell pandas, if you don't find the thing I'm dropping, ignore. So I'll show you what that looks like without this, okay? So the first one, df head 3, it's 0, 1, 2. I drop the first one, 1, 2, 3. I got rid of 0. The data now starts at 0. If I do this again, error. Key error. 0 not found in access. There is no row 0. So I can put back the code I dropped. I can put back errors equals ignore. Now I run it. No error. It looked for 0. It didn't find it. It moves on. Okay, cool. We're done. We're done dropping a row. And this is the data that I want it to look like. So I'm happy. The next thing is, what if I want to drop columns? Okay, I want to drop a few columns. So I want to drop the gross last week. I want to drop the gross difference. I don't like these columns. They're not useful to me. They're ugly, or sometimes they're actually just, I don't know, you just don't need it, or it is incorrect information. So you can create a list of all the columns you want to drop. All right, I've done that here. Then you do, instead of drop with the index, you do drop, and you specify columns. And you say, columns, drop these columns. Give them the column as a list. And then do it the same way we did before. In place is true, errors ignore. And boom, we just got rid of a few columns. And I'll do it again. No errors, because I'm telling errors ignore. Awesome. And go to town with this. Drop everything you like. Okay, so now we are done dropping our rows and our columns. Let's move on to 1.3, changing the type. So let's look at what the data types are, all right? Data type. So there's a few things that are wrong here, right? The only thing that's a number is the number of performances. Everything else is an object, which means it's a string. Pandas doesn't know what this is. So let's start first with the date time, week. We know that week is a date. I want to tell pandas, yo, this is a date. Treat it like a date. So recall from last module how to convert strings into dates. So the first method that we're going to use, there's two methods. There's the date time method, and there's the pandas method. Now, mind you, this is not code. This is a string representation of code. Right? So this looks a little different. That's how I can give it to you. Okay, so this is going to be a date time method. You're going to use the date time package. Oops, date time package. You do datetime.datetime str string p, which is parse time. So string parse time. Use this string and get me from this format. And it's a little bit of work. You kind of have to understand the syntax behind that. A much easier method is use pandas. You do pd.toDateTime. You put in that function, the string, and it's going to automatically give you what that string looks like as a date. So I can just do that here. I can do a .apply method. I can say take the column and .apply. So .apply means take the function I'm about to tell you and do that for every single row. And that's what's going to happen here. I'm going to run it. No errors. Do d types. And we got week as a date time. If you want to look at what that looks like, you could just, and it looks very similar to the one above. All right, this looks like with a slash, and this looks like with a dash. It doesn't really matter to you. The computer is going to represent them the way it wants. You can actually, if you really wanted to make it slashes, you can configure your notebook to show it that way, but it's a lot of work for something that's kind of arbitrary. So great, and this is what we really care about. Week is now a datetime object. Let's convert our data to numeric. So this is going to be a little bit more of a heavy section. Just put on your thinking cap. So recall gross is $1, right? $1. Well, let's just look at what it looks like here. Let's do df head, and let's only look at the first three. Right? You could print out the whole thing. I don't want to look at everything. It's going to take up too much space. So gross. So the problem with this is if this is a number, then I have commas that don't belong there, and I have money signs that don't belong there. So I can get rid of the money signs, and I can get rid of the commas. That's what I do here. So I'm going to say, go to this column, and make this a string if it's not a string already. The reason why you have to do that is because what if you convert it, and now it's a number? And then you try to replace the string. It's not, it's a number. You have to convert it to a string. So make this a string, then get the string, and replace the money sign with nothing. You have to do empty string. Okay. Nothing. And then take the string from that and replace the comma with nothing. Then make that an integer. Okay, and let's look what that looks like. Okay, so that looks much better. It looks like a number. There's a neater way to do this. So I can either do this method on top, or I could just say, get me the string. Oh, but this has to be a string method, so I have to say like this. Make this a string, right? Get me the string, and then replace any one of these characters with nothing. Regex is true. And what are these characters? The brackets say whatever's in here. So what's in the bracket? There's two characters. There's a escape money sign, which is money. Otherwise, it's going to think the money applies to internal code. So you have to say, which means $, or a comma. If I do that, it works the same. Okay. So I don't need that, and I don't need this. So these are two methods you could use. The latter is a little bit neater. I don't like this method because I don't like converting to strings and going back and forth. It's messy. Also, like, I can't really read this. It doesn't make sense to read. So what we're going to do is we're going to create a function. Then we're going to do .apply and use that function to convert to numbers. Just like PD to datetime lets you convert to datetime, we are going to create a function that will turn any number, including a percentage, into a number or a float. Here's how we do it. Okay. So this is to create a function in Python. I'll do it here. You want to create a function. So def, which stands for define my function. Okay. And then you want to open your parentheses and put something in here. So we'll say x equal, so x, okay? And then I'll say print x equals x. Make this an f string. That's it. That's whole thing we'll do is print something. So I'll do my function, and I'll say my function 7. It'll work because it'll say x equals 7, right? My function jello. Ooh, let's do one line. Jello, right? Easy, calm down. So there's another thing you can do that's really clever. You can give yourself a document string. So instead of a single string like so, you can give yourself, well, would this work? This is this, the function. I wonder if this will work. Yeah, this would work. And you're basically telling you, my function does this. Now what if you want this to take up multiple lines? So you can either give yourself a single line or you can give yourself a multiple line. So multiple line is just triple quotes, and you say, this function prints out your variable. So if you want to access your doc string, you could just do my function. No, you have to do my function. You could do question mark. It's going to tell you. And here you go. Here's your document string, right? It tells you down here, this function prints out your variable. Wonderful. Alternatively, you can just say help, and help will print it out. And it's going to say help. Help will just tell you the doc string. This function prints out your variable. So you probably want to say what x is, right? So x, x. So we'll say input, and do like x. We'll skip a line here to make it neat, right? Any variable. And maybe we want to do output. Nothing. Right, so behave the same way, and if I just do print hello my function, it'll tell me, right? This looks a lot nicer. Now I can understand, okay, x, got it, I know how to use this. So you're telling yourself, in documentation, you're telling yourself what the thing you did. Okay, so let's get rid of this, I don't care about it anymore. But what I do care about is the function I wrote down below. So here's the function name. Now, a tip, function names should be meaningful. If you're gonna create a function that does something, make that the function name. Don't worry about function names that are long. You can always rename something shorter, but as long as you understand what they do. The worst thing is when you write multiple functions, you can't remember which one does what, and you're stuck and you have to read it, and your documentation isn't good, and so everything gets messy. So, meaningful names. Okay, so this we're calling our function convert string to num. Convert, and so we tell ourselves what this is. This converts a messy string to an integer or a float. Params, which are input. S is a string. Output, an integer or float. Okay, and then we give ourselves another comment, which is really, you could. I did it because I'm teaching and I want you to really understand every single line. So the first thing we're doing is I want to see if it's an integer or float, don't do anything. Send it back. So I'll say if type is in, well, if type in, and I have a list. So if the type is an integer or float, if it's in this list, then return S. Just go, whatever you give me, give it right back. Okay, otherwise, so I have to dedent, right? So this is indented, so it dedents, so now it's not anymore if the if. And I'll say otherwise. S equals, and so RE stands for regular expression. So RE substitute, RE sub, and then I'm going to substitute money signs, commas, or percentage signs. And you can put anything else in here that you want. And substitute that with nothing. And then what should you substitute? This string. This is very similar to the s.replace method, but s.replace only works for pandas. It doesn't work for ordinary strings. For ordinary strings, you have to do re.sub. Okay, so we do re.sub, and now I've gotten rid of all the money signs, but it's not a number yet. So I'll say if. Now what if you have an empty string, right? There's nothing in there. So now it's going to be nothing. So I'll say if the length is less than 0, return none, meaning return that's blank. Because if I try to take the integer of a blank, it's going to break. So I have to say if there's nothing in there, do nothing. Then if there's a dot in this string, make this a float. Right? Remember, floats are decimals. And if there's no dot, return an integer. That's it. That's my entire function. And so just to see in action, I will, first let's get rid of help. I'm going to comment this out, and I'm going to say 800. And it's turned into a number. What if I do $800? It's still 800. $800. Percentage, percentage, percentage. It doesn't care. It's going to work no matter what. Awesome. What if I do 800.900? Boom. It turned into float, right? Because it's automatic. It's a very dynamic function. So now we've got something that's flexible. It's not, I mean, you could call it intelligent. You can even say it's an algorithm. It's an algorithm that converts string into a number. Awesome. You won't be the first person to have done this. This is something that most programmers do very regularly. Okay, so now I want to take this function and I want to apply it to this column. And let's see what it looks like. Boom, these look like numbers. And you see here on the bottom, the data type is a float. And it's 243, which means 243 rows. Awesome. So, and I didn't save this to anything. So it just did this operation and now it forgot about it. So that's fine with me because I'm now going to move on. I'm going to use this function on the following columns. I manually type these because I just don't want to make myself crazy and do anything automated, even though automation is nice. For this, let's just focus on the data. So these are the columns that are numbers. And I can just say, for each column, apply this method. But wait, what if this column is not in my columns? So here's what I'm going to do. I'm going to verify that these are in my columns. So I'm going to say, for column in these columns I just specified. If the column is not in df columns, which means not in my data frame, print that's not in the columns. So if you do this, oops, I have to run this. Okay. So, ooh, which column is not in my data frame? The column pay attention is not. So I will now get rid of this column. And let's verify it. Perfect. So that's great. So this is a manual step that you can do that will make sure you're paying attention to your code, and it will make sure you edit it correctly. That's a good way to do it. An even better way to do it is if you never have to pay attention. So here's how you can never pay attention. I'm going to put pay attention back in here. Okay, so now pay attention is in the list. So I'm going to say new numeric columns. Make this an empty list. For a column in my list, if the column is in df columns, then add it to my new list. Otherwise, don't do anything. And I'm going to print out the new list. Right? And you notice how pay attention is not in there. Because I said only if you're in my df columns. So I basically took the two lists and I just found the similarities. So that's all fine and dandy, but it's a little long. It's like la 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 la. So here's a neater way to do it. This is called a list operator. And this is very common in C, C++. And naturally, that will lend itself to having popularity in other languages because people will take what they've learned and bring it elsewhere. Cultural exchange, if you will. So this list operator basically says the same thing this other code. Which is easier to you? To write all of this code, 1, 2, 3, 4 lines, or write this? And if the former is easier, do that, but I will suggest consider this operation. So what we'll do is we'll say, well, I'll write it backwards for you, okay? So I'll say, for column in numerical columns, right? That's the first thing. So for column in numerical columns. Well, no, actually, let me just read it to you the way it's read. Basically, you're going to say, column for every column in numerical columns. That's it. If that column is in df columns, which is the same thing as saying my list equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I can say x for x in my list. And I basically just said, take each thing and go through my list. And I can say, x for x in my list if x is greater than 2. Boom. That's easy, right? So let's go back. Let's do it again. List operation says, x for x in my list. Basically, just go through the list and get me each one. If x greater than 2. I can even do other things. I could say x times 2 for x in my list. Right? I can do all sorts of crazy stuff. Okay. So here we're doing something really simple. I'm just saying get me every column that's in numerical columns if it's in df columns. And if I run this, boom, pay attention is not there. Great. I now do not need to pay attention. So I'm going to say for column in this new list, make the data frame column equal to this column that I set, but convert the string to the number. So I'm going to do that. I'm going to do that. Boom, we're done. That is efficient programming. So the next time around, all you got to do is throw in this function in the beginning, wrap it around all your numerical columns, and you're good to go. You'll never have to write this code again, unless it breaks, which it might. But this is the beauty of programming, is that you don't have to repeat yourself. Once you put in the work, it's yours to use. Great. So that took a little bit of time, and that's, I think, the end of the difficult part. So now it's going to get easy and fun. Now we're going to create a column for the year. So recall that df.week is a date time. So to access elements of that date time, you could say .dt, get me the date time component, get me the year, and that will make a new column called year. And if we look at it, year is going to be all on the side, 2015, which is correct. Awesome. We're now done pre-processing our data. Now, I did a whole bunch of steps, and I don't want to have to go and run all these cells every single time I load my data. It's going to get messy, especially if I'm using, dozens and dozens of spreadsheets and data forms, and now I have to write all this code every single time. So we're going to give ourselves a much neater place to do it. We're going to rewrite all that code in one spot. Fortunately for you, I already did it for you. So just pop open number 2, load data with all pre-processing up front. So I'm going to paste the function again, just because you have to define your function. Ideally, this will be located in another file, and you can just pull it in, but for now, you just paste it in the beginning. And then I'm just going to run this one block. This does everything we did prior. We did everything we did. So I'm just going to load my data and watch it get printed out. Boom. That's it. If you're going to be downloading files from the Broadway database, you never have to pre-process your data again, because you've done it here, and it's going to work for old spreadsheets with this format. Unless something happens with the spreadsheet and it gets a little funky, then you have to make sure your code is a little more flexible. But for the most part, this is kosher. So if you deal with automated reporting, if let's say your work sends out an email that's every single week that looks the same way with a specific spreadsheet, you can just build code that reads that spreadsheet, does something to it, and you never have to write the pre-processing code again. And now your life got a little bit easier. Fun. Cool. And we're back. Okay, so we are done loading our data. We've done all our pre-processing in one bunch, and now let's get into the fun part. Let's begin analyzing our data. So recall that we're working with big data, meaning we can't see it all at once. So if I tell you what's the date with the best week, what's the week with the best performances, the best income, you can't just look at it and see, because it's too big. Big data. And this is only 200 or 300 rows, but think of having millions of rows, which is this would work for millions of rows. The code would be, you would hit some performance issues, but for the most part, it would be okay. So let's analyze. We got a whole bunch of pieces. The first one we want to say is 3.1. What was the best week per year for the gross? So you can imagine there's probably a holiday or a week, maybe the Tonys. Which week is the best week for Hamilton the musical? So here's how you get the max value. So if I want to say, get me the max value, period. So here we go. I'm just going to create a new code. I'm just going to say df gross. Right, this is our column. I'm going to say get me the max. The max is going to be, there was one week that grossed, what is this, $4 million. Wow. Okay, that's a lot of revenue. That's not profit. Don't think that these actors and producers are cashing $4 million a week. There's lots of expenses and it's not profit. But okay, $4 million is still a lot of money. All right, I wouldn't mind having $4 million. So that's for all. How do I get it per year? So to get per year, you're going to do a very simple function. You're going to say group by, and you're going to say group by the year. And then you're going to specify which columns you want. I want the gross column, and you say get me the max value. So this is going to be, it's not a data frame, it's a pandas series. It's just like a column, but it's a column with an index. The index is year, and the values are, each year, here's the most amount of money you made for each one. Now, I don't need to just do it for gross, I can get it for all of the columns. I can just say, just get me the max for everything. And it's going to say, here's 2015, and here's the max value for every single one. Okay? It's not that meaningful. I just want the gross. But this is how you could do it. Okay, it's an aggregating function. I'm going to aggregate by year and do something to it. Okay, so what if I just want the date? So here's how you can get the date for the date of the max. So first things first, I'm going to set the index to the week. So instead of it being 1, 2, 3, I'm going to say the week is the row. So now, if I want to access row 1, I have to type in the date time. It's not good for accessing data, but it's great for manipulations like what we're going to do. So and I'm not saving it. This will not be remembered. It's not in place. Okay. Then I'm going to group by the year. And let's just see what that looks like with, and get the gross. And let's just see what that looks like with max, without the IDX. Okay, so max. So now, I just got the max, right? Because it's the same as before. But I don't want the max. I want the index of the max. So I can do IDX, which is index max. Here we go. And these are the weeks per year. So you notice they're all December. They're all about Christmas time. Except for 2020, which hasn't had Christmas yet. So we're on par for that trend. So it looks like Christmas week is the best performing week for Hamilton every single year. But I want to be able to see the week and the amount in one place. So here's how you can do that. I basically want to do what I did in the first step and the second step together. So here's what you can do. I'm going to create a new variable, df_ag. It's going to be the aggregated data frame. And that's going to be exactly what I did before, right? df set index, set that to week, group by year, take the gross, and then instead of saying max and IDX, I'm going to say .ag, which means aggregate. And .ag is a function which has open parentheses. All right? Ag looks like this. So I can say ag, and I can just say create a list and put in things. So I can type them in like sum, right? That's the sum of grosses. I actually don't want sum, right? I want max. I actually don't have to use strings because max, Python knows that max is the max. And I want IDX max. And IDX doesn't need to be in the string. So boom, there you go. I'm going to apply these two functions to this. Can you put in custom functions? Aggregate, count, value, unique? Try it. See if it's built in. If it's built in, rock on. Thank the open source creators. If it's not, you can write your own function and pass it in on its own and it'll execute it. But I caution you for doing that now. It's a little bit more advanced. It requires a little more understanding of data structures than we've covered. So here we go. Here is the index for each week and the max value for each one. This is no longer big data. I can look at the whole thing and reach a conclusion. I could say, okay, 2018 was a really good year for Hamilton. It looks like 2018 was better than any of the other years. It also looks like 2019 was a little bit worse than 2017. So maybe the popularity rose and it's dropping. Here's some conclusions you can reach right away. Okay, what would be even cooler instead of having to read it is be able to look at a picture. So let's create a data visualization of this. It's really easy, but before we do that, we have to rename our columns because IDX max and max are not meaningful. So remember, we can create a list and just set them equal to it. So because I only have two columns, I'm just going to do that. It's lazy, it's cheating, I don't care. I'm going to throw this out in the garbage anyways. It's not my pre-processing, it's just a little bit of manipulation. There we go. So now I have year, week, gross. So I could say, just get me the gross and plot because my index is the year. And it looks like this. Here's my year. Here's what it looks like. And that's much more beautiful. This is a lot easier to read than a chart with numbers. I can just look at it and go, 2018 was a good year. And it looks like maybe things are adjusting. We got a little bit of a curve. Great. And we're done answering this question. So what was the best week per year? The answer is Christmas. Christmas is a holiday season, is a great time for Broadway shows. Okay, what was the best performing week for Hamilton ever? That's very easy. It's much easier than the thing we just did, right? Here's the best week ever. It looks like this might be the holiday week of 2019. So what I can just do is I can say, get me the index of gross, right? IDX max. I'm just going to save that. And then let's do one thing at a time. Let's just run the first line code, okay? So I'm just going to run the first line of code. And I'm going to say, what is this equal to? Okay, this is the index is 181. I'm going to get the week. I can't just look up the week. So what we do is I'm going to say, okay, take the index, right? Get me that row. Get me the entire row where this occurs. And let's see what that looks like here. And this is what the entire row looks like. So to get the row, I can use the index by doing df.iloc, which means use the index integer. I could do .loc and type in the whole string if it has a name, or .iloc is the numerical index. And that works because my IDX is here. So it's great. Well, what if we do .loc? I wonder if that would be his. Well, 1230 and iloc 334 .loc. Yeah, it's .loc, excuse me. .iloc is the index location. .loc is the location specifically. Recall that our index is going to be one off from the integer because we dropped the first row. So we do .loc. Make sure you change the code correctly in your code because the notebook I uploaded does not have .loc. So we get a specific row using that code. Actually, yeah, because I can't save it backwards. It's going to make things chaotic. So great. And if I print that out, that's my max row. All right, you can do a sanity check. Gross is very high. Gross is very high. Good. So then I could just say, get me the week of that row. And I can say, get me the max of that row, which would be the same as getting .max, but instead I just get gross. And I'm going to print it out. And I'm going to say, the best performing week for Hamilton ever occurred on, max. Oh, did we get rid of it? Max DT. Max row. Max DT. Yeah. Let's do a sanity check again. Max row. Yeah, that's right. 404,000. Yeah. Yep. The best performing week ever for Hamilton occurred on the week of, well, it looks like the week after Christmas, so the New Year's week of 2018. And it made $4 million. I wonder if that's when Lin-Manuel Miranda made his last performance. Let's Google it. Lin-Manuel Miranda last performance Hamilton. And it looks like it's July 10th, 2016. So something else happened then that made everyone really popular. And if you're a Hamilton fan, you should comment what happened because I'm curious. Okay, so, I mean, you're definitely a Hamilton fan. If you're a Hamilton fan who knows everything about Hamilton, because we're all Hamilton fans. We're all Hamilton. Okay, I don't want to do my own impression of it. I'll save that for the performers who get paid to do it, and I will pay. In fact, I will pay to listen to them do it. Post a link to Hamilton musical. Okay, so how many people saw the show since Hamilton won the Tony Award? That's a great question. I mean, it's useful for all sorts of reasons. You could say Hamilton is the most amazing show in the world. Everyone should see it. How many people have seen it, right? Well, it's limited to the number of people who can fit in a theater. But maybe you want to, I don't know. This is the sort of stuff that is relevant for certain things. So, step one. I got you the date for the Hamilton Awards for the year they won it, the 70th Tony Awards. It's June 12th, 2016. So we're going to create a date time using the pandas method and date time Tony. If your name is Tony, be flattered that there is a variable named after you, but do not be mistaken. This is for the Tony Awards, not for you or birthday or anything. Great, so now this is a date time object. And I can filter using the following method. I can say df, so I'll first write a few, I'll write a few as it's written. So I'll say df week is greater or equal to the date time for the Tonys. If I do this, I'm going to get a column, and it's going to be, no, you're not, no, you're not, no, you're not, yes, you are, yes, you are, yes, you are, true or false. So that's great. And I can just say, get me all the rows that are true. And now, automatically, it's just skipped everyone who's not. So let's get rid of this guy. Let's do down here. This is written for you here. Right? Great. So you use brackets to filter as such. This is the sort of thing that when you first look at it, it doesn't really make sense. When you stare at it and you say, okay, I know what this is doing down here, and this, that, and here. You know, feel free to break things apart and run it and just understand what's happening and change some things. Be like, oh, about less than or equal to, what that looks like. All right. And then one equal sign will not work. You have to do two equal signs because one equal sign will make it equal to the value. Two equal signs will say, is it equal to this? And there's 1 week that is equal to it, right? So that's the sort of things that you can do. Okay, so great. And we no longer need this. So I'm just going to set this back to normal. I'm going to, okay, great. So get me the number of people who've seen it. So I'm going to say here is my filter, the same one I did previously. Then I'm going to say, get me the column, which is the seats sold. And then just give me the sum of that. And let's print it out. 2 million people saw Hamilton since they won their Tony Award on Broadway. That's a lot of people. That's a lot of people to see any show. And think about how the number of people, there's like for reference, there's 300 million people in America covered. U.S. population. 327 million. So there's once over 60 years, 0.5% of all Americans have seen it, or so, something like that. My maths. You can just type it in if you want to do the math on the computer. How many people have seen it on tour? How many people have listened to the music? So this is really something that has made a significant impact. So that's pretty cool. When you see this thing, you go, 2 million people saw it. Well, it's not 2 million people, because you could see the show 10 times, and that would still be counted. So, but conceptually, right, this is the sort of thing that is really cool. You're like, wow, 2 million people saw the show. Imagine you wrote this. Imagine you wrote Hamilton. You're like, 2 million people saw a show I wrote. Like, okay, it's something to like, you know that you have a show that's on Broadway, but like you see 2 million, you're like, wait, like that's as many people that live in like, I don't know, like most cities. Okay, cool. Well done, Lin-Manuel Miranda. All right, so let's go on. How many people saw Hamilton each year? So that's easy, right? We know how to do this. We group by year, and I say, get me seats sold and sum. That's super easy. Boom. So you note how after 2016, it kind of is full. It looks like the theater has just been at 100% capacity since then. Maybe the prices are adjusted. But 2020 is a lot lower for 2 reasons. One, 2020 is still ongoing. Second, COVID. So there's definitely going to be a major impact on these numbers as we go forward. Imagine you're doing this analysis in a year from now. Hopefully COVID's well beyond gone and we're all kind of back to normal. You might see, and let's just assume that Broadway is super safe and everyone's disinfected, everyone is healthy, and people see shows at the regular rigor. You would want to correct your analysis to adjust for seats sold per year, and then create another graph that maybe says seats sold per year divided by the number of weeks of operation, because 2020 was missing X number of weeks from it. These are sort of things you might want to think about. But the question isn't how many people saw Hamilton for each week. The question is how many people saw Hamilton for each year. And that is the answer to this question. Okay, so the next one, visualize how average ticket price changed over time. And then we want to distinguish before and after Hamilton won the Tony Award. So this is a great conversation about how a show should expect their sales to take place when they win a Tony, or if they win a Tony, and how they should plan for. Imagine you're on a marketing team and there's the producer walks in and is like, all right, tell me the post-Tony plan. You're like, well, if you don't win the Tony, here's what we're going to do, and if you do, this is how it's going to change. And you'd be like, look, this is what happened with Hamilton. Now, Hamilton might not be the best example because that's a whole other ballgame, but at least you'll have a talking point, right? And what if you are part of the next show that's just like Hamilton? Rock on. That sounds so fun. Okay, so before we do anything, let's just look at what average ticket price looks like and just do plot. This is what it looks like. Boom. So a few things. One, this is super easy. And if you're just doing quick analysis and you just need to look at this, you'd be like, got it. And you just go do your thing. This will work. This, is a really efficient method for just exploring and poking around. But the x-axis has no dates. It's just numbers. And those numbers can be meaning anything. We know that the numbers are the index that are related to when we started. Okay, and then the Y column, you kind of have to know what you did. It's the ticket price. Okay, so we want to fix those things. So the first thing is I'm going to create a daytime for Tony. I'm going to create another one, right? And then I'm going to create a color. So I'm going to create a color that basically says, go to the week column and apply the following method, lambda x. Now, if you don't know what lambda is, this is a specific type of function. We're not going to get into exactly what lambdas are. Just copy what I wrote here. I really want to explain, but I want to get to the end of this. So apply the following function, x green if x, which is the value in the row, if it's greater than or equal to the date of Tonys. If it's more recent than the date of the Tonys, make it green. Otherwise, make it blue. Okay, so that's going to remember a new column with the date. So what I'm going to do is I'm going to say, give me a scatter plot. X is equal to week. Y is equal to the average ticket price. The color is equal to color. And the data is equal to data frame. So instead of setting the column for each one, I could just give the string, and then it'll automatically allocate it. Okay, and let's just see what that looks like when I do just a scatter plot. Great, and it's not connected, We'll get to that in a second, but this is what it looks like. Okay, so very clearly the sales have gone up tremendously since the Tonys. And what we're going to do is we're going to add a vertical line. And I'm not really going to get into how this is taking place. Just copy it and let it work. This is going to be the date time for the Tony Award. Boom. And I mean, you don't really need to see the line. You kind of see the actual data points. But still, like it's a nice way of being like, here, right line. Okay, cool. So a few things. I do have the dates now at the bottom because I set them equal to it, right? But I don't have them as a connected line. So this has to do a little bit of how matplotlib interacts in the back end. But basically, if you do .scatter, it treats each object like its own, so I can change the colors. But if you do plot to make it like a line, the entire line is one object. You can't change the color of an object twice. That's really frustrating. So what you have to do is you have to go and loop through each color. That's what we're going to do. First, I'm going to set the index, df type series, right? So this is, I'm going to make just like we did in the group by, I'm going to say, instead of 0, 1, 2, 3, make it the week, the date. And then I'm going to say as follows. For each label and group in the color, grouping by color, so it's going to first do blue, then it's going to do green, plot the average ticket price, and make the color that color. So let's see what that looks like. And I'm doing a whole bunch of stuff here, so I'm just going to copy this out just so you can see what just this first portion does, right? Great. So that's nice. That's what I want it to do. This is a lot of code to do something very simple. It's frustrating, but I basically want to say, make a line chart and change the color. There's other plotting libraries that do this much more easily, but we're just going to operate in this default mode. Okay. So now that you've seen what this does, I'm going to go back here. I'm going to add a vertical line. I'm going to add another vertical line for the Tony following. I'm going to add a legend for these so I can use the labels. I gave myself a label, right? My label's here. I'm going to give myself a legend. I'm going to give myself a title. I'm going to give myself a Y label. I'm going to show it. So that's much nicer, right? Notice there's a title on it, right? I did that here, PLT title. There's a Y-axis, right? I can make it bold. I can change the color if I wanted. I can make the color green or blue. So that's great. So this is really nice. Also, I want to make a bigger figure. So I want to make this, it's too small. So I'll do PLT figure. And I'll just say, and it's got to be a tuple. So I'll do fig size equals. I'll make it 12 by 4. It's going to be really wide. Much better. Right? 12 by 4. Great. And if you want to save this, so you can like save the image, and that's going to give you like a really bad version. Another way you can do it is plt.save fig, and then you have to write the file name. So I'll do Hamilton ticket price .png. And if you save the fig, if you show the fig before you save it, you're gonna get error. So you have to save it before you show it. Okay. And if you're doing this on Colab, that will now be saved to this file. Okay. And then you can download this manually. So I'll say yes. Oh, is it giving me a preview? Oh, that's amazing. Yeah, so it's a preview. Wow, love that. It's giving me all sorts of cute ways to look at it. Okay, great. I don't need to look at it anymore. Okay, great. And if you were operating on your computer, your local computer, it would just download it to the folder that you were operating in. I don't know why we're getting issues here. Oh, it's putting the plot up here. I don't know what's happening here. Get out here. Okay. I have no clue what this is. I've never done this before. Oh, it's giving it a new tab. There we go. I don't know what's happening here. Get out of here. Get out of here. Okay, reformatted things. Got it. Great. So we're done visualizing it. And that's it. We're done. Let's move on to 3.6. 3.6 is which month has the poorest attendance. So we all have our assumptions about the worst week to see a Broadway show. Well, let's find out what that is exactly. Well, not worst week to see a Broadway show. It's probably the best time to see a Broadway show. You save yourself the most money. So yeah, let's say you're operating on a budget and you want to be like, this is the time where you buy tickets on Hamilton because the week that does most poorly. So also fix it with 2 hashes so that we get the right Okay. So I'm going to create a new column called month. And I'm just going to group by month. And I'm going to measure it by capacity. Now, capacity is a percentage. I don't want to do number of tickets sold because some months are longer than others, extra days. I want to look at the number of people who are in the seats. Okay. So I'm going to say df aggregate is this. And then I'm going to say, let's just get rid of this here. Okay, let's just view what this looks like. Boom. Awesome. So here are each month, and I don't need to do the index by because it's organized by month. So this is really hard to distinguish, and the reason why it's created on 100% is because, however this is set up, the max. I'm getting some messages on my Slack, so let's make this disappear. Go away, Slack. Hopefully this conversation won't continue. However it's set up beforehand, 100% is not truly 100%. Maybe there's a specific number of seats that are reserved for X, Y, Z that they only release, X number. Maybe it's standing room. Standing room are extra 10 seats, and now you get above 100%. That's an example of how that occurs. And if you're curious, it doesn't make sense, I'd encourage you to go contact someone who works in Hamilton or works at the Rogers Theater and Richard Rogers Theater and say, hey, I'm doing this data analysis and I'm getting this interesting number. Can you explain it to me? And I imagine they will give you the answer. And how cool is that? And you get to be part of a community of people who are maybe, helping each other out. Maybe you'll write some article about what this is. That'd be cool, and I would definitely read it. And if you know the answer, comment it, because I want to know. Okay, so I just want to get the minimum, and equals the index of the worst day, the worst month. And the poorest month is 11, so November. November is the worst month for Broadway. Now, it's not true. November is not the worst month for Broadway. But for whatever reason, Hamilton's poorest performance is November. It could be, oh man, when was Hurricane Sandy? It could be Hurricane Sandy, like however many years ago. Hurricane Sandy was 2012. Wow, I'm off by 3 years. There could be something very specific that happened during a month in November. There could be a injury for an actor. There could be a really terrible weather that happened for 3 days straight that made no one show up, right? There could be a snowstorm that canceled an entire performance. These are some of the things, these are some of the things that might be this tiny little discrepancies that you don't want to just assume straight up by just because you did some quick analysis. So I would say is like do a sanity check, maybe run the metrics on another thing, maybe look at gross and compare them and try to see the whole picture. Because big data is big, you can't look at the whole thing at once, but also don't enter the space of big data and just focus on one tiny aspect and ignore the rest. That's all related. It's your job to be responsible with it. Okay, so we know it's the poorest month is November for Hamilton for some reason, but that doesn't. I don't feel satisfied with that. I want to be able to see the answers, so we're going to visualize it. Okay, so I'm going to say aggregate plot, make this a bar chart, and I gave a comment. I said this color is the Hamilton color. And this is not the true color, but I went to the website and copied and pasted what I found. So I'm going to make the figure big. Okay. I'm going to give my title, and I'm going to change the Y label. And let's comment this out just so we can see what this looks like. Wow, okay. So here's the capacity per Broadway, capacity per month, Hamilton on Broadway. And they all look the same. So are they all the same? Well, we know that there's a tiny, tiny percentage difference. Now, 1% is a big deal. 1% of 3,000 is, 300 is 30. That's 30 seats less that they sold a month. I mean, that's, if each seat's $200, that's a few dollars, So they don't look that different. So we're going to shift to a log scale, a logarithmic scale. And now it looks like this. Okay, cool. So is the worst month really November, or is it August? So I'll tell you. Every month, there's two periods where Broadway generally sees a downtrend. There's definitely the winter months, which for Hamilton looks like it's not really an issue because Hamilton is the type of show that perhaps people come to see, and they're coming to New York to see Hamilton. But in the summer, there's actually a lower attendance in August than there is during the rest of the year. And it's surprising for a lot of reasons. One, Europeans travel a lot in the summer and come on vacation, but they come on vacation during July. And in August, a lot of Europeans are actually not in, at least later in August, they're not in New York anymore. They're either in Europe or they're getting back to normal. Also, the school year starts late August, early September. so people are busy at that time. Also, New York is miserable in August, so a lot of New Yorkers leave. And since these are tiny percentage points, tiny percentage points, these could have been, there's extra 20 seats that go to house managers that they get to give to special reserve parties like celebrities or show affiliates, and they're just not interested in coming in the summer because it's hot out and they want to go do something that's nice. There's all sorts of reasons why that might take place. In November, I mean, this is weird. Actually, I should preface this. Analyst jobs, the job of an analyst is to take this picture and make it make sense. My job is to not do that. I don't do that. I don't make things make sense. It's not my job. I don't do it. I'm just guessing. But I'm just rather than telling you what's what, I'm imploring you to find explanations for this. And the coolest thing, at least one of the things that I find most fun, is take a chart that you've made. So let's just say this is the chart you made. And I don't love it because the details are too small. So capacity is probably not the metric you want to do. You probably want to do number of tickets sold. You probably want to do number of tickets divided by number of performances or something. And you want to say, okay, throw this out to some friends who see Broadway shows all the time and be like, hey, listen, can I show you this chart? What do you think about this? And see what they say. And it's fun. Okay, cool. So we're done talking. And if you want to save it, you can just do this. Save. Now DPI is the pixels per inch. I don't know what D is. I should know, but I actually don't. And if you save it, now it's going to save in here. And you can make, instead of 350, you can make it 300. You can make it extremely high quality. So you can overwhelm your computer if you make it too high quality. But the point is, you can get really high quality graphs. We are done 3.6. And we're up to the conclusion. Oh my God, we're almost done. So by now, you're able to explore data on your own and answer whatever interesting questions you might have. I encourage you to practice on this data set, since you're really familiar with it, and others. So in 4.1, go ahead and ask yourself a question. Question you want to solve about this data set. So you might go in here, you'll say, what was the most expensive ticket ever sold? Okay, and then the code is going to go down here. So we'll say df, and we'll do, well, first I want to see the columns because I don't remember what they are. Okay, df head, A, and I want to say top ticket price. Okay, cool. So I'll say top ticket price. I'll do max. $998. Now, if you ever read an obscene headline that says these tickets for Hamilton are going for thousands of dollars, it's true. This is the most expensive tickets sold for Hamilton directly, meaning all those tickets are secondary markets. That's its own conversation. I won't go into it. Well, I'll give you one tiny snippet. There's a tremendous amount of money that is lost by Broadway shows to secondary markets. Not because the secondary markets are mean and sneaky and they get in there and no one knows. It's the technology that exists in Broadway to change the price is still, I would say, behind what exists in the secondary markets. So if they change their ticket price from $400 to $900, then they go to $1,200, that creates a lot of opportunity for risk on their side. A lot of Broadway producers are like, I am not going to piss off my audience and start selling tickets for thousands of dollars. We're going to set these absolute limits. And the theater owners are on board with that as well. So even though there's potential revenue loss, there is like the safety, the technical level safety, but there's also like the just a lot of infrastructure reasons why that exists. But at the same time, like there's a lot of lost revenue taking place from it. And if you're able to solve that, go do it because people need it. So now we know it's $998. You can even say, I don't want to just know that. I want to group by, group by. I can say group by year, and then get me. Well, actually, you want to do it this way, right? You want to do df group by year. Then I want to do this. I want to get max. So this is how much it went for every year. So after 2015, it went up to 1,000, and it kind of just stayed there, which is great. Now, if I went instead of year, did I have month saved? What if I do month? I mean, year and month, right? So I could actually just do group. I can group by more than one column. I can just do year, month. So this is going to give you a huge data set, right? And I can just plot that. Boom. So it just shot up after they won the Tony, and then it just kind of stayed there. Except for maybe here, it went up by like $10. So this tells you a little bit about Hamilton's dynamic pricing strategy. They have caps, and it's going to be similar for most Broadway shows. There's going to be a ticket price cap. They will never go above. They'll stay below. They'll go up and down a little bit, but they'll never exceed that roof. That, and I because it's so rigid and it looks like it's there for a long time, I'm going to say it's maybe not the producers, maybe it's the theater themselves. The theaters do have leverage to set limits on tickets. So this is something that's a little bit curious, right? Like, if we know the secondary tickets are going for more than $1,000, why have the primary tickets not fluctuated at all? They should have gone up or down a little bit. So that tells you a little bit about the dynamic ticket pricing that's taking place. What if we do average ticket price? Okay, that's dynamic pricing, right? Because now you see it fluctuates. It doesn't stay the same. So this is what dynamic ticket pricing looks like. The ticket isn't just, it's not staying in one spot. What about minimum? What's the best time to see a show? Okay, so it looks like, whenever this was, you could see Hamilton for $220 something. The average ticket price, which means the cheapest ticket is going to be much lower than that, maybe even $100 or so. So that looks like it took place just after start 2019. It's maybe in like February 2019 or something like that. I don't know. Cool. So if you want to see Hamilton, how much will it cost you right now? About $250. Great. So I would encourage you to kind of go through and ask more questions and perform it here. So this concludes Module 4. I'm just going to close this here. Great. And you can save your notebook, and so you can just do File, Save. It's going to ask you to save a copy in my drive, right? So you'll save a copy in your drive. Well, I have it in my drive. And now it's good to go, and you could just rerun it, and you have that code from cell 2, so the next time you want to run it, just open up, run this cell here, then open this up here, and now you're good to go, and you can just start running your analysis and ask yourself more questions, do this in sections. Work today for an hour, try tomorrow for an hour, and go through this data set, see what cool stuff you find, and if you're watching this on YouTube, give a comment, tell the community what you found. So with that, thank you for being part of this class. I think we're going to do one more class. We'll do a Module 5. I think after that, that's going to conclude the introduction, and then from there we might do some more advanced topics. So thanks for being part of this, and make some noise in the comments so I feel enthused, because part of me, I'm doing this to give back, and I want to hear from you. So that's all.